All right, the decibel scale. So this is about recording intensity of sounds, or comparing intensity of sounds. So the decibel scale, I naught is the intensity of a just discernible sound, I is the sound being analyzed intensity, and the decibel level is given by D equals 10 log of I over I naught. So given that I naught is 10 to the negative 12 watts per meter squared, what is the decibel level for a sound with intensity of 800 watts per meter squared? Now, in the guided notes, they talk about different levels. So 0 would be like the quietest sound that you could hear. 40 is like normal conversation, so about how loud I'm talking right now. 80 would be for heavy traffic. 120 for like a concert, a loud concert. And then at about 160, human eardrums are likely to rupture. Other animals could hear wider ranges. But if you think about what that means, so that's a scale of 0 to really 16, because there's that 10 times the log in front. So 0 to 16. So that's powers of 10 of 0 to 16. That's a 16 power of 10 spread, which is why using a log scale is useful for the decibels. And I have written here in light blue a comment about the decibels. So 10 to the negative 12 is just discernible. Okay, that is 1 with 10 zeros in front of it. This number, 0.000000000001. That is immensely small, especially when you compare it to 800. So that's why having this log scale is useful, because the spread of discernible sounds is really wide. And in order to get a kind of a handle on it, we're going to use that log scale. Okay, so the decibel is 10 times the log of the sound being studied. So in this case, the sound I want to study is 800. And the discernible, barely discernible, is 10 to the negative 12. Now, there's a couple different ways you could think about doing this. You could just plug this in right now. Log of 800 divided by 10 to the negative 12. I hope that works. Yeah, it does. Okay. This. Now, you could just do that. You could also realize, oh, well, negative power makes reciprocal. So if I pull this back up into the numerator, I have 10 times log of 800 times 10 to the 12. Depending on your calculator, this might actually be easier to type in. Okay, so if I did that, log of 800 times 10 to the 12th. Oops. So when I did my parenthesis, it was up here in the exponent. It needed to be down to close out the, there we go. So 14.9, but then it's times 10, right? So 149. So pretty loud, right? Pretty loud, because a concert was 100 and I think 140. So this is like you're at an extremely loud concert. All right. Now the difference between the decibel and the Richter scale problems is the decibel one, they give you that I naught is 10 to the negative 12, and in the Richter scale they just tell you that it's some amount times I naught. So they don't actually give you I naught itself.